Verify 1 plus secant x over secant x equals sine square x over 1 minus cos x. Now what we need to do is start on one side and arrive on the other. Or maybe we could simplify the left side to something simple. And if we can simplify the right side also to that expression, we are good. Now, when both sides look complicated, then I want to just start on one side and simplify as much as I can. So I'm copying the left side, and if the denominator is a monomial, then I want to rewrite this as two separate fractions and see if that works. So 1 plus secant x over secant x means I have to divide 1 by secant x, and then I also have to divide the secant x by secant x. So we can separate it into two fractions. Now 1 over secant x, what I'm assuming, or before we try to prove any identities, we want to remind ourselves of some simple trigonometric identities. In this box, you're going to see these four identities, which say that all the other trig ratios can be expressed in terms of just sines and cosines. So if you look at the right side, it has just sine or cosine. And then once we write that, we also want to know if there is a relationship between sine and cosine. And they are related by the Pythagorean identity, cos square plus sine square equals 1. And then there are two more Pythagorean identities. If you know them, that's great. If not, at least know this one. Now 1 over secant is cos x, and this is plus 1. Now from here going there seems a little bit complicated. So what I'm going to do is I'm going to start on the right side now. Right side is sine square x over 1 minus cos x. Now, in addition to the simple trigonometric identities, we also need to know some algebra. And in particular, for this problem, I'm going to use this identity. A minus b times a plus b is a square minus b square. Or going in the reverse direction, if you see a square minus b square, you can always factor it down into a minus b and a plus b. So difference of squares. Do I have difference of squares? I don't see anything, but notice sine square could be written as 1 minus cos square x. Why is that? Because from the Pythagorean identity, if you subtract cos square x from both sides, then you get sine square x equals 1 minus cos square x divided by 1 minus cos x. That's the denominator. Now notice the numerator is difference of squares. 1 is 1 square. So we can certainly factor that into 1 minus cosine x and 1 plus cosine x. Your a is 1, b is cosine x. And then your denominator is 1 minus cosine x. So notice there is a common factor. Now we can cancel the common factor. So what we are left with is 1 plus cos x. Now, we could simplify the right side to 1 plus cos x. We simplified the left side also to 1 plus cos x. So what we have done is we have shown that the left side is equal to the right side. So when you have done that, you're done.